I'm getting negative 0.5 roughly. All right. All right, so how about tangent of negative 3? Again, notice that the angle here does not have a little degree sign. It's not tangent of negative 3 degrees, as you can see here. It's just tangent of negative 3 with nothing written beside it. So you assume that's radians. All right. This would be degrees, and so you would have to be in degree mode to calculate that correctly. If you're in radian mode and you want this, you're going to get the wrong answer. So be sure you're in the correct mode on your calculator before you go through these computations. So this is in radians, so I'm in radian mode, so I'm okay. So I take negative 3, press tangent, and I'm getting about 0.1425. So I'll put my wavy equals for approximately 0.1425. Alright, so you should be able to do this on your calculator easily. Now, the calculator doesn't understand secant, cosecant, and cotangent. I forgot to put a T on there. Cotangent. So you have to do those computations yourself. For example, if you want the secant of pi over 7, there is no secant key on your calculator. Your calculators will have sine, cosine, and tangent keys, and also inverse sine, inverse cosine, and inverse tangent, or arc sine, arc cosine, or arc tangent. We'll get to those inverse functions later on in the course. So what do you do with that? Well, you could program your calculator to handle something like this. If you want to learn how to program the calculator, your manual should tell you how to do that. But most people don't want to do that. So you just rewrite this as 1 over cosine pi over 7. And then do that computation. Now, there's a relatively quick way to do this on your grapher or scientific calculator. You first take the cosine of pi over 7. So I'll write that in there. And I want the number for that. And then what you want to do is invert that, right? You've got cosine of pi over 7, you want 1 over that. So your calculator should have a 1 over x key. Should be a key labeled 1 over x. In other words, x is whatever appears on the screen at that time. You press this key and it'll automatically invert that for you. It'll put 1 over x. Or other calculators will have x to the minus 1 power. And mine has 1 over x. So I'll just press that. That's a quick way to do it. You don't actually have to go through the division of 1 over cosine pi over 7. Just use your quick key there. And I'm getting 1.1099 approximately. 1.1099, which you should be getting as well. Now, if you graph sine and cosine, for example, you can graph the sine function, make a table. As I said, you can keep going around this unit circle for s, and you can keep getting the same. Notice if you go around the unit circle, you'll go through the same points that you were at before. And so the sine and the cosine values will repeat as you go around. Alright, so if I go beyond 2 pi, 2 pi would be all the way around one time. If I go beyond 2 pi, I'll be repeating the same sine and cosine values. Remember, the cosine and sine values are the x and y coordinates of the points. So essentially, well, we start at 0 when x, well, you can call this the s-axis now. So when S or, you can think of that as X instead of S for arc length. When S is 0, the sine is 0. So you can plot that point. And you can plot the other points as well. On the S-axis, these would be arc lengths. So you could say that's pi over 2, which would be 3.14, approximately 3.14 divided by 2. And you've got pi, and you've got 3 pi over 2, 2 pi, and so on. And when you graph it, you'll see it makes this classic wave shape, and it'll repeat. Because you're going around the unit circle, the values repeat. So this is what we call a periodic function. Cosine graph looks similar. You can look at this on page 372 in your book. And that's what we call a periodic function. Now, a function is periodic if there is a positive constant p such that f of x plus p is equal to f of x for all x in the domain of the function f. And the smallest positive number p is called the period of the function. Alright? So the period of this function is 2 pi units. Alright? So every 2 pi units, basically it repeats. And there's also something called amplitude. Amplitude is half the distance between the maximum and minimum function values. Now, what are the maximum and min function values for sine and cosine? Well, remember, sine and cosine are just points or x and y coordinates on the unit circle, right? And the unit circle has a radius of 1 unit. So the biggest x value will be 1. The biggest y value will be 1. The smallest x value will be -1. And the smallest y value will be -1. So the sine function, for example, has a maximum of 1 because, again, that's the y coordinate. The maximum y coordinate on the unit circle is 1. And -1 is the smallest. The same thing applies to cosine. So the amplitude would be half of the distance between the maximum and minimum, and half of the distance would be 1/2 of 1 minus a -1, which would be 1/2 of 2 or 1. So the amplitude of this graph is 1 unit. Same thing with a cosine function. Alright, so I'm going to stop here and let you look at the rest of these graphs. Look at the graphs of tangent on page 378. You'll notice a lot of vertical asymptotes. Well, since tangent is sine over cosine, every time you have a cosine equal to 0, you're going to have a vertical asymptote because that's where the function is undefined. And since the cosine's in the denominator. And so you've got lots of vertical asymptotes. That's wherever you have cosine equal to 0. And as I said, these cosine values repeat. So you're going to get zeros quite often. Alright, let me give you an assignment on this. This is section 5.2. And do 1 to 45 every other odd. Also 59, 67, and 75. 59, 67, 75. So there is your homework assignment. So thank you. Have a nice day.